Hi students, and welcome to another HSC chemistry video in the acidic environment series. If you're following the upload sequence on YouTube, you'll notice that there's a few out of numerical sequence here, and that's because due to being in the lab at the beginning of the week and not the end of the week, we're actually going to bring forward your experience of volumetric analysis and titration. So the first thing we need to do is just have a bit of a look at some of these important concepts as you will start to do them on Monday. So the first thing we need to do when we're looking at our volumetric analysis through the process of titration is that one of the important components of titration is the solution of a known concentration. We must have a solution of known concentration if we're to calculate the concentration of an unknown solution, and that's our ultimate goal. A solution of known concentration is called a standard solution, just a solution whose concentration is actually known and accurately known. We can prepare these by adding a certain mass of a reagent to a defined volume of solution. So mass can be converted into moles, and then our moles can be then divided by the volume to give our final concentration. Prior to any preparation of a standard solution, we must use a primary standard. Now, there is a difference between a standard solution, which is a solution whose concentration is known, and a primary standard. And there are going to be certain conditions that must be met for us to select a primary standard. This is because not all substances are suitable to be used as standards. Some of them, even when they're made up into solution, may absorb moisture or carbon dioxide from the atmosphere, which may slightly change their pH. That affects the concentration and will affect our results. Any of these, however, that are not suitable to be used as a primary can be standardized against a primary standard, and then that way their solution can be calculated and hence known. And then we can use these in further titrations down the track. So there's a couple of important conditions that must be met for a primary standard. The first of these is purity. It has to be a pure substance. We can't have a mixture. We can't have impurities in the substance because they may affect the results. It must be soluble in aqueous solutions. So we have to make sure that we can dissolve it in water. Our acid-base titrations are carried out in water, and therefore our primary standard must be able to dissolve in water. It must have sufficient reactivity. We must be able to use it in a neutralization reaction. If we can't use it in a neutralization reaction, then it's no good to us as a primary standard. It must be stable, so it must not react with the atmosphere. It cannot deliquesce, it cannot absorb moisture out of the air, it can't absorb carbon dioxide out of the air, because if it does in the water, that'll produce a slight acidic solution of carbonic acid. We don't want that. It's going to change our results. So stability is critically important. And finally, constancy. We want to make sure that once we've made up that solution, it will stay at that concentration that we've calculated if we put it away and bring it back out again. Now, when we're carrying out a titration, there's also a couple of very important pieces of equipment, and you may well be asked questions about how we look after this equipment and how we prepare it for use in a titration. The three pieces of equipment that are critically important, and we're going to spend just a little bit of time in this video focusing on each one, is our graduated pipette, our burette, and also the conical flask, which is going to be almost always our reaction vessel. So firstly, the pipette. You can see this is a 25 ml pipette. It's got a graduation mark on it, so we know exactly where the 25 ml mark is. This is called a bulb pipette, and it delivers a precise volume of liquid once we make sure that the bottom of the meniscus of our liquid is sitting right on that line. You'll actually notice that it is a circle. It actually goes all the way around the pipette, and there's a reason for that. If you can see the whole circle, you're not looking at it directly on. You should just see the line, and that tells you that you're measuring accurately. In order to use a pipette, we must rinse the pipette several times with water. First of all, to flush out anything that may have been there previously, and then we need to rinse our pipette with the solution that we're going to put in it. Liquid in pipettes is often called an aliquot, and you may see references to this word, an aliquot of a particular substance. It was used in a titration. So just to give you a bit of an idea of the terminology. This is a burette, and this burette is one of the type that you're likely to be using during your titrations. It's a very accurate piece of glassware, and it needs to be treated with respect and with care. There are also certain procedures that go with the use of a burette. It should be cleaned and rinsed with distilled water again, flush out anything that may have been previously in the burette. And then again, we must use the solution that we're going to put into the burette. Now, when we're rinsing with the solution, it has to come through the tap and out the bottom, but also if we very carefully rotate the burette, we also allow it to roll around the inside of the burette and flush out at the top. So when we're rinsing, we must rinse the top and the bottom. Often we'll use a small funnel placed at the top of the burette in order to fill the burette with the solution that we're interested in. It's important that you make sure that you break this seal on that, because sometimes you get a little bit of a seal and the liquid can just run straight out and over the top. A waste beaker is always important to put underneath the burette in order to collect any excess, because we don't want that going into our reactant vessel. The burette liquid is called a titrant. So the aliquot for the pipette and the titrant for the burette. Now, last important piece of equipment is the conical flask, and this is our conical flask. It's our reaction vessel. It's probably more appropriately or correctly termed an Erlenmeyer flask. And this is where we're going to have our neutralization reaction to take place. It should be clean and dry, but it can be rinsed with distilled water. We're going to be adding an aliquot, or we're also going to use a primary standard that's going to go in here. That will give us a known number of moles, and it's that number of moles that we're going to use to do our calculations against our substance that's in the burette. So the number of moles is important here, not the concentration, and hence we don't have to rinse it with the solution. We just need to rinse it with distilled water. Very importantly, don't forget the indicator that you've chosen to use for this particular titration, otherwise you'll just overshoot by a long way. And popping a white tile or card underneath the flask can just help to get an idea of where some of those subtle changes occur. We'll go into the actual process of volumetric analysis or titration in the next video. Thanks for watching.